Today we're going to finish the section we started yesterday. We started 3.2. We just did the substitution portion. Today we're going to do the other portion. So same section as yesterday, just day number 2. Okay, this looks like a lot, but I will tell you right now, this is in your book. So if you don't feel like writing this, it is in the book. It's in section 3.2. There's 2 boxes. One is the substitution method. One is the combination method. The combination method goes by several different names. Elimination is probably the most popular name. I like to call it the opposites method, but really these 3 names are interchangeable. The book says linear combination. So if you're looking for this in the book, that's what you should look for. But when we're doing this method, the first thing we want to do is multiply one or both of the equations by a constant to obtain coefficients that differ only in sign from one another. So basically you want to get opposites. Either on the x or the y, you want the coefficients to be the same number but opposites. Once you do that, you add the revised equations from step 1. This eliminates a variable. That's why they call it the elimination method sometimes, because you eliminate one of the variables. And then you solve for the remaining variable. Once you get one of the variable's values, like either x equals or y equals, you substitute it back into one of the original equations, and you solve for the variable. So I'll give you some time if you do want to write this down, but like I said, it is in the book. So the first thing you want to do is make sure that one of the variables has opposites. So check out the x's. The coefficients here are 1 and 1. The coefficients for the y's are -1 and +1. So are there opposites on any of those? Yeah, the y's are opposites, right? Once you have opposites, you can add the equations. When you add the equations, add the x's. 1x plus 1x is 2x. Whatever variable had the opposites, those should cancel out. And then 3 plus 5 is 8. After you add them, you should only have one variable left. If you don't have one variable left, if both variables are still present, then you didn't have opposites and you need to start over. Solve for the remaining variable. I'm getting that x equals 4. Once you know what one of the variables is, you can plug it back into either equation. I'll just plug it into the top. So 4 minus y equals 3. Subtract 4 from both sides. Negative y equals -1. So, of course, y is going to equal +1. So, I think right now it's 4, 1, but I'm going to check. When I plug it in here, I would get 4 minus 1 is 3. When I plug it in down here, I get 4 plus 1 is 5. So, I know for sure this is the answer. What are your questions on this? Number 2 is going to be a little more difficult because I don't currently see opposites. Does anyone know how we can get opposites and on which variable would you like to get opposites? Yes. If we multiply the second equation by -3, then we'll have opposites on the x's, right? Now, when you multiply, make sure you distribute to every piece of the equation. So the bottom equation is now -9x plus 15y equals -51. I'm going to rewrite the top equation right below it just so I can add a little easier. I'm not going to change anything, just rewriting. Once you have opposites, you can go ahead and add. What happens to the 9's? Yeah, the -9x and the +9x cancel. I'm left with 17y equals -51. Divide both sides by 17. What's y going to equal? -3. Great. I am halfway done with the problem. Once you have one of the variables, you can just plug it back in. I'll plug it into the top. So right now I have 9x plus 2. Instead of y, I'm going to write what y equals. And that equals 0. So 9x minus 6 equals 0. Add 6 to both of the sides. Divide by 9. Reduce. You get 2/3. So I'm pretty sure my answer is 2/3 negative 3, but of course I'm never satisfied until I check. If I plug it in here, that would give me 6 minus 6 equals 0. If I plug it in here, it would give me 2 minus negative 15. That does equal 17, so this is definitely my solution. What are your questions on number 2? Do you guys see any opposites? No, not yet. The signs are different. That's nice. So we don't have to worry about changing any signs. But what do you guys think we should do? Yeah, we can multiply the top by 3. When I do that, make sure you distribute the 3 to every term. You get 6x minus 9y equals 15. Uh-oh. What's happening here? Yeah, those both cancel. So I have 0 equals 27. Does 0 equal 27? No, so there is no solution here. All the variables canceled. I got something that was false, so no solution.
Would it be like that if you did a different way on the second equation?
No matter how you solve this, you should always get no solution. It doesn't matter the method you solve it. We could graph it. We could use substitution. We could get a different kind of opposites. Like if you multiply the top by 6 and the bottom by 2, they should still always cancel out. So yeah, no matter what the method, we should be getting no solution. All right, we need some opposites. Any ideas? Yeah, let's multiply the bottom by negative 5. There's different ways you could do this. You could get 12s on the x's, a positive and a negative, but this is the easiest way. You only have to multiply the bottom equation. So this is going to turn into negative 15x minus 5y equals positive 20. I'm going to rewrite the top equation right below it so I can add a little easier. This is going to be 4x plus 5y equals 13. Once you have opposites, you can go ahead and add. So this is going to be negative 11x equals 33. Divide both sides by negative 11. X is going to be negative 3. Once you know one of the variables, plug it back in. I'm actually going to plug it into the second equation. I think that's going to be a little easier for us, since there's no coefficient on the y. So that's going to be negative 9 plus y equals negative 4. So I'm coming up with y equals 5. But you know me, never quite satisfied. Let's check. If I plug it in here, I get negative 12 plus 25 equals 13. That one works. Down here I get negative 9 plus 5 equals negative 4. That works too. Any questions on this? Do you guys see opposites? No? Anyone know how to get opposites? Negative 2, where? Top, good. So that would give me negative 4x plus 10y equals 8. Ready to add. Those go away. 13y equals 13. So y is going to equal 1. Once we know the value for y, plug it back in. It doesn't really matter where you go. I'll just go to the top. 2x minus 5 times 1 equals negative 4. That's just going to give us a 5, so I can add 5 to both sides. And x is a half. Alright, let's check. If I plug it in right here, I'd get 1 minus 5 is negative 4. That works. Here I'd get 2 plus 3 is 5. That one works too, so this is definitely the solution. Questions? All right, any ideas? Yeah, the bottom by -3 looks like a good place to start. So that's going to be negative 9x minus 6y equals 9. You can rewrite the top equation below it. So 11x plus 6y equals 1. Go ahead and add. I'm getting 2x equals 10. So of course x equals 5. Plug it back in. I'm going to plug it into the second equation this time just because they're smaller numbers and that makes me feel better. When I do that, I get 15 plus 2y equals -3. 2y equals -18. Y is going to be -9. So 5, -9. If I plug that in, I'd get 55 minus 54 equals 1. That works. 15 minus 18 is -3, so it works there as well. Questions? All right, I'm pretty sure this is our last example. Who knows, there might be one more. I think we're going to have to do a little extra work on this one. Ideas? Yes. Change the y's to 12s. Okay, so what do you want to multiply the top by? Positive 4. And then the next one by? Negative 3. Good. Make sure you keep one positive and one, well, keep one negative, make one positive. Good. So when I distribute here, I get 24x minus 12y equals -12. For the second one, I get -24x plus 12y equals 12. Uh-oh. What's happening here? Yeah, everything is gone. I get 0 equals 0. Does 0 equal 0? Yes, so if we were graphing these, it would actually be two lines right on top of each other. So this is many solutions. What are your questions on the elimination method? Most students prefer the elimination method. I like all three. Questions? Yes?
So when you check your answer, does it matter which problem? So does it need to go in the original one?
Yeah, anytime you check your answer, I would plug it into both originals. Because if you mess up in the multiplication and you plug it in here, it might work, but it might just be that you didn't go back far enough to catch your mistake. So if you plug it into the original, yeah, you can guarantee. Other questions? All right, here's your homework. It's basically finishing the homework that you started last night. So it is a little shorter than normal assignments, but hopefully not too bad for you. All odds, so you can check your answers and bring questions tomorrow.